serve water, which the water flow is controlled by this control valve. So when this valve opens or closes, then you change the water flow inside of the omega cooler, and when you have more water flow, you have better cooling. Lower water flow means worse cooling. What else do you need to maintain the cooling media temperature? You need a measurement. This is a temperature measurement behind the cooler. Because this hydrogen which is flowing out here is going back into the generator. So I need to control the temperature before it goes back into the generator. What you see here is the closed loop control. We just, for the first step, leave out this one with the generator load. Here you can see the set point. The set point for the temperature can, for example, be 40 degrees. For the hydrogen temperature. Set point 40 degrees. Here you have the measurement. Let's say, okay, the measurement measures a temperature of 45 degrees. Then you have a calculator here, which calculates the deviation between set point and measurement. So when we have 40 degrees set point and 45 degrees measurement, then we have a deviation of 5 degrees, right? 5 degrees plus. And when the controller sees, okay, I have a deviation of 5 degrees plus, then the controller opens the control valve to have a higher water flow, and then you can cool down the hydrogen better, so that you have 40 degrees here. That's a quite simple control loop. You have a set point, you have a measurement, you calculate the deviation, and then the controller reacts. What is this here? The generator load. Why is this coming into this control loop?
If the generator load must increase cooling.
Yes, the generator load affects the temperature of the hydrogen. Because when you increase the generator load, the dispatcher calls you and says, I need more active power of your power plant. So you increase the gas flow of your gas turbine, and therefore you increase the generator load. Maybe from 250 to 300 megawatts. Then the temperature of the hydrogen must go up because there's more current flowing on the stator. So you have more heat which comes from the stator into the hydrogen, so the hydrogen temperature goes up. When you don't have this, then it takes a little time until the control loop sees that the temperature goes up. You increase your generator load, and then maybe, I don't know, 5 minutes later, the temperature goes up. And then the control loop sees, okay, I need to open the control valve. When you put in the generator load into this control loop, then you can make the control loop a little faster. Because this is a curve. This rectangle here is a curve where you say, when I raise my generator load by 50 megawatt, for example, then the hydrogen temperature goes up by 5 degrees. Just an example. So what this is when you raise your generator load by 50 megawatts, then you have 5 degrees coming out of this rectangle because of this curve. The situation is, you have set point 40 degrees and the measurement is 40 degrees. You didn't have this time that the temperature is going up. So you have set point 40 degrees, and because you raise the generator load, you subtract 5 degrees from the set point of 35. So then the set point of 40, so here is 35 coming out. Set point of 35. Then you have a measurement of 40, and you have a deviation of 5 degrees. And then the controller opens the control valve, despite the temperature hasn't changed. It's just to make the control loop a little faster. So this is one control loop that you have in your power plant for the cooling media temperature. Yeah? You have many. Yeah, you can ask a question. You have many control loops in your power plant. Yeah? Which some of them we will speak through. Yeah? So this is one of them. Yeah? I understand. Are also in the cloud. Yeah? So you can have this picture also. These pictures also. This is the casing of your generator. Yeah? Here you can see these are the blades, yeah, the rotating blades symbolized by a fan. Yeah? On the one side and on the other side. Here the yellow arrows are the hydrogen. And here you can see some temperatures, yeah, winding temperatures. Here you can see the water cycle, yeah, with the cooler here. Yeah, water coming in, cooling down the hydrogen and going back. And also for the